I would like to tell you about the geometric way to add vectors. So in the previous video I explained that vectors correspond to directed line segments and standard position, meaning that their tail is the origin. They start at the origin, 0, 0. So, well, the vectors are vectors, let's say in R2, are ordered pairs of real numbers, okay, written as a row or as a column, and there is an algebraic way to add them, right? You just add the corresponding entries together. So if you want to add the vectors, let's say 2, 3, right, you want to add it with the vector -1, 6. Sorry. Then you just add the first two entries together, so you get 2 plus -1, so 2 minus 1, and then you get 3 plus 6. Okay, and this will give you the vector 1, 9. Okay, I'm writing them here as column vectors, okay, because maybe this doesn't seem to be very natural to you, but this is what we're going. Most of the vectors in this course are going to be column vectors. Okay, so all right, and if you have a vector in R3 which has 3 components, you do the same thing with each of the 3 entries. Okay, so one can see this is the algebraic way to add vectors when the vector is represented using either a row or a column with 2 or 3 real numbers. Okay, but what if we decide to draw arrows to represent vectors, right? So is there a way to add the vectors by adding the arrows, the directed line segments? Well, the answer is yes. It's not something that we're going to use much in this course, but it is something important to know. And if you take a course in physics and mechanics, for instance, then you'll see that you can add forces by adding vectors geometrically. So it's important to know the geometric interpretation of addition of vectors. Okay, so let me move this up here. Okay, and all right, so let me draw some vectors and then see how to add them together. So let's say we've got a vector that will, I'll take a vector that starts, let's say, here. Okay, maybe one vector will go this way. Okay. Okay, have another vector. Well, maybe I can use a different color. Maybe I'll draw it green. Okay, so also starting, well, I'll take this. Let's say that this is the origin. Oh, okay. So I want to draw another vector starting from there. So maybe this vector could go like this in this direction. Okay, so maybe it is this vector. Okay. All right, so I can give these names. Well, maybe the first one could be U, the second one a V. Okay, so I will underline it here. I should have kept my blue marker for here. So let's say I'm calling this, let me lower this here. Okay, so this is U, underline, and this is V. Now I want to add them together. Okay, so what I can do is I take V, okay, and I move it, always keeping it in the same direction of the same length. Okay, I move it in a parallel way so that its tail is at the head of U. Okay, so if I do this here, okay, so let's see, this is, yeah, I've got the angle here, and I need also, so I'm going to try to move this in a parallel way, but I also want to get to draw a vector that's the same. I want to draw a directed line segment that's the same length as V. So let me see, I have to measure a bit the length of this one. Okay, 1, 2, 3. Okay, so I'll go here. Okay, so all right, so I've got the right orientation. I start at the head of U, and then I'm going to draw a vector that's the same length as V. Maybe I'll draw it as using just as dotted vector like this. Okay, so okay, and I want to make it the same length as V. So I think this is about right. Maybe I should have again use a different color, but anyway. So okay, so this is like the translate of V. Okay, so you have to imagine you take V and you move it. You move the tail of V. You move it along U, starting at the origin, moving to the head of U, always keeping the same orientation. Okay, so this that dotted arrow, it's another directed line segment that is also associated to the vector V. Okay, so the horizontal and vertical displacements are the same. It's just that if you illustrate V using a directed line segment instead of position, well, the tail is at 0, and here, well, the tail is actually at the head of U. Okay, and what's the sum? The sum of these. Okay, so I'll go for another color. So the sum is going to be the vector that is in standard position, so it will start at 0. Okay, and it will end. It will end here. Okay, so the sum is actually going to be this vector. I will just need to connect these. Okay, so this is about right. Okay. Yeah, I think this is good. All right. Okay, so now this vector, this yellow vector, this is, well, I can say directed line segment instead of position, so it's just associated to its corresponding vector. So this is actually U plus V. Okay. So this is the geometric way to add U and V together. Okay. Well, it's doable in 2 dimensions, maybe even 3, but we'll see later on in this course that we'll have vectors and any dimensions, and then there's no way one cannot draw a picture like this. Okay, even dimension 4. Okay, but this works in dimension 2. Okay, so this is called the head to tail rule. It's also called the parallelogram rule because I could have I can complete this into some parallelogram. Right, so now I have to be careful which color I use, but okay, well, maybe I'll do the other side green. Okay, so if I want, I could add another dotted line here, like this. Okay, and then and then what I get, forget about U plus V, you get a parallelogram. We've got 2 sides, okay, we've got U and the opposite side that's parallel to U. We've got V and the opposite side is parallel to V. Okay, so all these 4 sides form a parallelogram. Okay, and the sum of U plus V is the diagonal there. Okay, so this rule for adding u and v is also called the parallelogram rule. Okay, and then one, I mean, you can, right, if you have two vectors, you can always add them, but also if you have three vectors, right, you can also add three vectors. So let's say if I had a third one, so I'll draw a third one. So I'll go again for another color. Okay, so maybe I'll pick some red this time. Okay, so maybe I'll draw another vector, maybe here. Okay, maybe I'll start it here. I'll start again at 0, and I'll draw it in this direction, like this. Okay. All right, I could, so this is, maybe I could call this one W. This is vector W, okay. And I can add u, v, and W. So if I want to add u, v, and W, I can first add u and v. Okay, and then well, I will add W. Okay, so I need to add W to u plus v. So I take my W and I just move it in a parallel way. Okay, so I'm going to draw, I'll go to the head of u plus v, and I will draw a vector that is parallel to W. Okay, so maybe I'll indicate it with a dotted line, like this. Okay. All right, so this vector is parallel to W, and now what is the sum of u, v, and W? Well, you apply the head to tail rule to u plus v in that translate of W. So the sum, well, it's against a new vector, so I can use a lot of colors. I might as well choose another one. I had yellow, maybe the sum was going to be orange. Okay, so again, I start at the origin. I start at 0. Okay, I just want all these vectors to be, they're always in standard position, except when I need to add two vectors and I have to translate one of them. Okay, so if I add these, okay, so I need to connect 0 to the head of that vector. So I do it like this. All right. Okay, and now this orange vector, this is u plus v plus W.